hold on. All right. Want to welcome you to the 15th International Mars Society Convention. We're meeting at a unique time. It's going to be a unique conference, that's for sure. As you may know from, well, not just the schedule, but the event that is coming up on Sunday night. And we'll have a lot of occasion to talk about the Curiosity landing, both its technical and scientific sides, its political implications, which are manifest. It is an event of enormous importance for the future of Mars exploration. If the mission succeeds, it will be the best Mars exploration mission ever. This Curiosity has about an order of magnitude more instrumentation than the Mars exploration rovers. And you'll hear all about that from the scientists who are going to be speaking to you. And it may make profound discoveries. It has the ability to sniff methane and to discriminate between isotopic methane from biogenic sources and non-biogenic sources. So conceivably, it could detect life on Mars. It could discover all sorts of things. Who knows? But if it fails, the Mars program right now is in an extremely fragile state because the missions that were planned have been dislocated, and the either need to be restored or a replacement program has to be put in their place. And if the mission fails, given how NASA has put so much eggs in one basket, and it has decided to land it with a novel landing system, whatever the failure mode is, people will say it was so obvious that it would fail this way. How could you not have taken this weakness into account? Really, that's what it always is. After the fact, it's always completely obvious that this weakness was there. And no doubt there'll be some memo from some engineer somewhere who expressed a concern about that particular issue, and that will make it more of a scandal. How can you ask for more money when you threw away $2 billion and so forth? So we will have to fight a very determined defense to reestablish the program under those conditions. So there's going to be a lot more discussion of that. There's going to be discussion about the Mars, robotic Mars exploration program tonight, a panel discussion, which will, by the way, include not only outsiders such as myself and people who are sort of in between, like Jim Bell, who will be speaking to you, but also the very insiders, the Jim Green, the head of the NASA Mars robotic program, will be speaking. So we'll get it from all sides. But what I'm going to talk about right now is how to restore the human exploration program, which, if in anything, is in even worse shape because it has no goals at all at the moment. We currently have a human exploration program, which is still spending about what it used to spend, but it has no nominal goals. It's not going to the moon. It's not going to asteroids. It's going up and down to the space station, and that is serving one useful function of helping develop certain commercial space capabilities, but I don't think it can be justified on that basis alone. It has to serve a broader purpose than that. Now, and you must understand there's another factor here, which is the so-called fiscal cliff. The fiscal tsunami, which is coming. Now, the United States has gone into enormous deficit spending over the past 4 years. Now, this is not due to NASA. NASA's budget this year is the same as what it was in 2008. But the rest of the federal budget has increased 40%. Okay, if you can imagine that. And yet, one of the first places that could conceivably be gone to wipe out, to try to rectify this situation would be NASA. And if it does not have a compelling mission, this ship that's adrift is just going to be swept away. So what does a space program we can believe in require? It must have a compelling mission. And I would argue to you that simply flying up and down to the space station is not a compelling mission for sending humans into space. I would argue to you that returning to the moon, while more interesting than flying up and down to the space station, is also not a truly compelling mission. Return to the moon 50 years after we were there the first time. But humans exploring Mars, okay, resolving the kinds of scientific questions that there are related to Mars, the search for life, resolving the question of the human future, which is, will we be a multi-planet spacefaring species, or won't we? I mean, Mars is the closest place that this could be done. If you can't make it there, you can't make it anywhere. So do we have an open or closed future? This is what we're going to resolve on Mars. And also, there's another thing, which is a question that's put to the nation, which is, do we still have the stuff to do stuff like this? Are we still a nation of pioneers? The United States is the only country, to my knowledge, whose national anthem begins and ends with a question. Okay? And the second question that it ends with is more interesting. Who does the banner still wave over? Does it still wave over the land of the brave? Does it still wave over a nation of pioneers? And that's another question that we're going to resolve here. Okay? Now, if you do say we're going to embrace Mars, because it is where the challenge is, it's where the future is, it's where the science is, then you really have to do it. Shortly before NASA, or the administration rather, announced the cancellation of the robotic Mars missions, which we in the Planetary Society had more or less revealed back in October, but it wasn't acknowledged by NASA, and it wasn't acknowledged by the administration until February. The week before that, I got called up by a high-level NASA official who said, look, we're about to announce that we really are canceling the missions, and Squires and these other people are all going to explode, and we really could use your help. So what we're doing is putting together a planning group to plan a human Mars mission for the year 2047. And I said, did you just say 2047? And he said, yeah, 2047. 2047 would be a very good year for a Mars mission, because at that particular year, the planetary alignment. And I said, did you just say 2047? And then I explained to him with all the tact that I could muster that I was not interested in being part of such a sham, and that his job was to restore the missions that he could actually restore, which was 2016, 2018, and not put together, some smoke about how we have a visionary program that we're going to do in the year 2047. Okay, so it must be proximate, and if it's to be proximate, it must be practical. In other words, you don't propose the most complicated mission plan you possibly can in order to make all sorts of fanciful technologies mission critical and include everyone in the mission. Okay, you have to figure out how you can do it if you really want to do it. The mission leadership must not be feckless, which means must not be seeking to find excuses not to do it. If you don't want to do something, you can always imagine reasons why it's difficult, impossible, complicated, really we should be put it off. You take any great venture, Apollo, the Normandy landing, you name it. Okay, or even the kind of robotic missions that we're doing right now, there's always risk. You can say, look, maybe we should resolve this first. Maybe we should do this, and then we can do. No, you have to go for the throat. And of course, one of the prime examples of the fecklessness right now of those who wish to avoid Mars missions is to say, well, we can't do it until we can resolve the space radiation issue, because the radiation's going to be there, and but. It is a fact that the cosmic radiation in interplanetary space is a factor or two larger than is in low Earth orbit. We've known this for a long time, because the Earth's magnetic field does not block cosmic rays. The Earth blocks out half the cosmic rays, and so if you're in orbit around the Earth, you get half the cosmic rays, you are free space. And as a result, in fact, due to long duration stays on Mir and the space station, like about 10 astronauts and cosmonauts have received cosmic ray doses comparable, or in some cases greater, than they would have gone to Mars and back. And no radiological health effects have been observed. So, and the calculated probabilistic radiation doses of these people is on the order of 1%, which is why among 10 people you don't see anything. But if we keep doing it, some of them, we will see something once in a while. But it's the same dose we're encountering right now. Okay? And to avoid going to Mars until we have warp drive so we don't have to encounter this dose is basically to avoid doing the mission. Mission success must be the highest priority. Now, this sounds like apple pie, but it's not. Okay, because, for instance, mission success means actually flying the mission. Okay, if you put safety above mission success, okay, well, the safest program is not to fly. So if safety is your highest priority, not mission success, you never fly. And there's an infinite number of precursor missions, technology developments, testing programs, all sorts of things that someone could propose that you might do before you go to Mars that would notionally reduce the risk of going to Mars, although many of these things, say a lunar base, carry risks of their own. But even putting that aside, there is an infinite number of such preparatory things that you could propose doing. And if you do a significant fraction of them, you never get to go. Okay? So now this does not mean you should take risk on willy-nilly, but at a certain point you do have to fish or cut bait. And the mission needs to be initiated in the present. I mean, it's ironic that the NASA, the current administration, in canceling the Bush Moon program, said, oh, we're more visionary than that. We're going to go to Mars. Okay, but much further out. That the same administration that says they want to go to Mars cancels the robotic missions. In fact, yesterday, Administrator Bolden says, we want to go to Mars and it's going to be an international program. We want to do this together with the Europeans. And I submit to you that if you want to go to Mars together with the Europeans, it would be a good idea not to renege on your commitments to go to Mars with them on the current missions. And in fact, I heard the news about this statement by Bolden in the presence of a couple of Europeans who just cracked up. So this is what you have to do. So, in short, okay, things like this, gigantic interplanetary spaceships. I mean, look at this thing, the giant nuclear electric spaceship. It's quite large. Mars is there for scale. If this is what is needed to go to Mars, we're not going to Mars. Now, how can you actually go to Mars? Okay, you do need a launch vehicle. A heavy lift launch vehicle will do it. We need something in the Saturn V class. This is not an impossibility. We cut the contract for Saturn V in 1962. We flew it in 1967. It was a 5-year development, and it was done by people who did not yet have push-button telephones. Okay, this can be done. You can then launch things directly to Mars. And by the way, it doesn't take 2 years to fly to Mars. It takes 6 months to fly to Mars. Mars Odyssey was launched in April of 2001. It arrived in October of 2001. That is 6 months. That was done with 20th century technology. And so you can go to Mars. You first launch, you send to Mars an Earth return vehicle with no one in it. Okay, then 2 years later, you launch to Mars every 2 years. You launch 2 more boosters. One sends another Earth return vehicle. The other sends a habitat with a crew of 4 astronauts in it. Okay, there's one design of the Earth return vehicle. We send it to Mars unfueled. It lands on Mars. With a small rover, we deploy a small nuclear reactor, 100 kilowatts. That's like 130 horsepower. It's the same amount of power that's in a medium-sized American car. Makes the power, run a pump, suck in the Martian air, reacts CO2 with hydrogen brought from Earth to produce a very large supply of methane, oxygen, rocket propellant. On later missions, we'll use Martian water. We won't even have to bring hydrogen from Earth. But I would suggest on the first mission bringing the hydrogen. It's only 5% of the propellant weight, after all. Now you got a fully fueled Earth return vehicle sitting, waiting for you on the Martian surface. Okay, there's the chemistry. You react hydrogen with CO2. You make methane and water, keep the methane, electrolyze the water, make oxygen, recycle the hydrogen. This is very well understood technology. In fact, it's 19th century industrial chemistry. So you've got a fully fueled Earth return vehicle waiting on the Martian surface. In the next year, you launch another Earth return vehicle and a habitat with a crew of astronauts in it. Simple tuna can hab, similar to the ones that we use in our Mars Desert Research Station and Arctic Station, okay? Except that this does have a solar flare storm shelter. There's two kinds of radiation in space: solar flares, cosmic rays. The solar flares you can shield against. They're only protons with energies of about a megavolt. They can be stopped by 5 inches of water or food and water wastes. We have enough of those provisions on the ship to create a shelter. The cosmic rays, you're going to take the dose, but it's just not that large. Okay? From a probabilistic point of view, it's a lower risk than smoking. So in fact, if you send smokers to Mars, you'd be reducing their cancer risk. Okay? And as I said, there's a bunch of astronauts and cosmonauts that have already encountered this dose. Okay? The one health factor we have seen in space is zero gravity health deterioration. I recommend using artificial gravity, which we can do by tethering off the burnt-out upper stage of the booster that threw us to Mars. This avoids the muscle and bone deterioration of zero gravity. Okay, so we have a fueled Earth return vehicle on Mars. Habitat is on its way to Mars. It goes and lands there. If it does not land close enough, we have a second Earth return vehicle to land near them wherever they did land. Okay, so here, this is an actual photograph of the Mars base. So you have the Earth return vehicle, you have the reactor providing power for the base, some backup power from solar panels, the habitat, which is where the people live, a pressurized rover. To deploy the reactor, we used an unpressurized rover. That's a backup vehicle. And in the foreground, you see a greenhouse. This is not mission critical. It's an experiment in growing food on Mars for the benefit of future missions and future bases. Now, we're on Mars a year and a half. That's the appropriate amount of time to be on Mars to get a good launch window home. If you try to get back to Earth much sooner, you add a great deal of delta V to the mission. You make the mission much more expensive. You also make it riskier because you have to fly through the inner solar system, what's called a Venus flyby. And there's no point, because if you're going to take 6 months to fly to Mars and 6 months to fly back, you should spend a year and a half on Mars, not 30 days on Mars, because the benefit of a Mars mission is the exploration time on the surface of Mars. And if you do the year and a half, you get more time at less risk and less mass. So that's how it should be done. Only people who are trying to sell advanced propulsion systems with very high capabilities pick these harder mission plans, and they actually make the mission much more difficult. Anyway, we're on Mars for a year and a half, exploring to find out all kinds of things about Mars. Most importantly, however, of course, looking for signs of past or present life. This is the critical question. Mars is the Rosetta Stone for letting us know whether life is a common phenomenon emergent from chemistry in the universe. Life appeared on Earth practically as soon as there was liquid water here, within 200 million years, that is, after liquid water appeared on Earth. Mars had liquid water on its surface. These are Viking photographs, networks of water erosion features all over Mars. If the theory is correct that life is a naturally emergent phenomenon from chemistry, it should have appeared on Mars. And we can maybe find fossils. Maybe we can drill underground and find extant life, because there's a very good chance, I believe it's a certainty, in fact, that there's liquid water underground on Mars. And that is where Martian life could still persist, if it is there today. So we go to Mars, we do a bunch of these landings, set up a networks of habs allowing you to revisit multiple locations, explore continent-sized areas on Mars. But after a certain number of these landings have occurred, we'll know whether there was life on Mars, or if there is, and what its characteristic forms were, how far it developed. And then the primary question on Mars is going to change, which is to the question of, will there be life on Mars? Because Mars, it has on it all the chemicals and other resources needed to support life. It therefore has the substances needed to support industrial civilization. And if we can go to Mars and figure out how to make use of these resources, going beyond the Mars direct mission with its making of fuel and oxygen for the return mission, but learning how to grow crops on Mars, learning how to make bricks, ceramics, glasses, plastics, metals, tubes, wires, habitation structures, we can develop the technologies that allow human beings to become self-sufficient on Mars, and at that point, Mars becomes habitable. Not through a physical transformation, that will happen eventually, but through an intellectual transformation. Once you know how to live somewhere, then it becomes habitable for you. The Earth was not originally habitable for human beings. The human beings are not native to the Earth. We're native to Kenya. The Kenyan rift valley. Yeah, we're tropical animals. That's why we have these long, thin arms with no fur. We couldn't live in Colorado, where I live, which is considered a very desirable place. Any truly primitive human, a human without clothing, which is a technology after all, without fire, without houses, could not survive a single winter night in Colorado, okay, or in most of Europe or most of Asia. And we became a global species by developing the technologies that allow us to become global. We will become an interplanetary species by developing the technologies that allow us to live on other worlds. And Mars is the place where this can be done. And if anyone's interested, the same set of hardware that is used to allow us to build bases on Mars could be used to build bases on the Moon as well. Okay? But so here is the primary hardware set we need to establish humans on at least 2 new worlds. But the issue here is getting to it. It is an amazing thing, okay? People think that we accomplished Apollo because the NASA budget was 4 times as big during Apollo as it is now, okay? Well, it wasn't, okay? The average NASA budget, if you take all of NASA's money from 1961 to 1973 and you put it in today's dollars and add it all up, by my calculation, it comes out to $19 billion a year. Okay, there's a paper going to be presented at this conference where someone else has done the calculation. He says, no, it's 22. Whether it's 22 or 19, it's practically the same as NASA's budget is now. It's not an order of magnitude larger. It's a much larger fraction of the federal budget because the rest of the country was poorer. The United States had 1/4 of the GNP in real dollars in 1961 as it has today. Okay, and it had a major military opponent that it had to face off against. And despite the fact that it was much poorer, and despite the fact that it had much more costs for large military expenditures, okay, it nevertheless succeeded in doing Apollo on the same budget as NASA has today. It's a question of focus. It's a question of will. You know, NASA has the same budget today as it had 4 years ago. 4 years ago, there was this thing called the shuttle program, which was $5 billion. Okay, this is 30% of NASA's budget. That's gone. Everybody said then that, well, the shuttle's gone, we'll have all kinds of money to do planetary exploration and other stuff. And in fact, we're doing less. 4 years ago, we had Curiosity being developed. And they were preparing the Hubble repair mission and preparing a Europa mission and so forth. It's a question of focus. You can easily dissipate the money if you don't have the focus. And that's the key question here. The way to get to Mars is to decide to do it. Thank you. I'll take questions. We got time for a few questions. By the way, the plenaries this morning are half an hour, and there's a lot of them, and we're going to have to do them by the numbers. So if somebody's speaking long, we're just going to get the hook. It's not personal. It's just how it is. All right. Questions? Anyone? Sir? I think at this point we do. It is true that we have a very interesting development with an entrepreneurial space company called SpaceX, which has now developed a medium lift launch system on a budget about 1/10 of what would be conventionally accepted as necessary in the aerospace industry. Okay, but nevertheless, it remains the case that 3/4 of SpaceX's money came from NASA. Okay, Elon Musk did put in a serious chunk of change, no doubt about it. And the reason why they managed to build this thing, develop this system for 1/10 the cost, is he was spending money as if it was his own, because part of it was. So what we have here is proof that, in fact, the space program can be conducted much more economically, but we still need a space program to fund it. This is going to have to be a national program. Sir? Do we need international cooperation? I'm agnostic on this question. Okay. Do we need international cooperation? No. The United States could do this alone. Okay? Or we could do it as a joint program with the Europeans. Or we could do it in the style that this grand event currently going on in England, the Olympics, which is on a competitive basis, a friendly competitive basis, okay, because this is the kind of space race I'd like to see, one motivated by an Olympic spirit of competition, not of hatred, but of different nations, different parts of the world competing with each other to demonstrate excellence, to see who can do the most to advance human knowledge in the human frontier. I think this is the best form of cooperation, cooperative competition. In the back.
Why has NASA's focus changed, and what has it changed to? Because I can't figure out what it's changed to.
Funny you should say that. I think they've lost focus. Period. It is amazing to me that, for instance, you could cancel the moon program and not save any money. Okay. It is amazing to me that you could cancel the Mars missions and not save any money. Okay. So that you have, frankly, the two flagship programs of NASA both being canceled without saving any money. I believe that there's certain people in the administration, John Holdren, who is hostile to the idea of a visionary space program. He is hostile to the notion of human expansion into space, and he's written so in other places. I frankly cannot see the reason, any other reason behind this. Now, other people may take nominal reasons, but if you take the Mars robotic missions, this is the most successful program in NASA. It's not politically controversial. It's one of the programs in NASA that brings home the bacon. Okay, and yet you kill it. And to me, that has to be, look, if you want to kill a baseball team, you get rid of its best players. Okay, you know, there's lots of pork there they could have gone after, but they didn't go after it. Okay, so they're going to be spending $2 billion a year this year refurbishing the shuttle launch pads, even though there are no shuttles. Okay, and that's why they couldn't spend $300 million on the Mars program? This doesn't make sense. So now, there could be other people that simply are not focused on it. I happen to believe that President Obama has not thought much about the space program one way or the other. It never has been central to his concerns. So you have entropy, and you have certain other players who have thought about the space program, but not in a way that we would want. And some unfortunate developments. We're done. Okay, got to wind it up. Thank you very much. I believe our next speaker is going to be Jim Bell. Jim Bell is the president of the Planetary Society, and he is also, of course, a Mars scientist. He has written a book about the Mars rover mission, which he was a major participant in. And